Hello everyone, welcome to Quality Thought YouTube channel. Today we'll see the topic called time and distance. This will give the relationship between time and distance as in the name mentioned. Actually this concept is related to speeds where we have main concepts as time and work. So it tells in the given time how much distance a person or a vehicle will be travelled, or to travel a certain distance how much time is required by a person or a vehicle. So let's see some concepts before we moving to the questions. Let's see the concepts. So we all know how the speed is calculated. So the speed is calculated. The speed is calculated as distance divided by the time. The speed is calculated. Speed is equals to distance by time. From this equation we will clearly understand that the speed is inversely proportional to the time taken. The speed is inversely proportional to the time taken. That means, see here, see we have written speed is equals to distance by time. So more is the speed, less is the time taken to travel a distance, or more is the time, less is the distance it is travelled. That means less is the time taken. So if you are travelling with more speed, you require less time to travel to a particular distance. If you are travelling with less speed, you need more time to travel to a certain distance. So from this we can write the distance d is equals to speed into time, or we also can write distance value is speed into time. We have speed is equals to distance by time. Then how will you find out the time? The time is nothing but distance by speed. The time is nothing but distance by speed. See here, we will have to know few things here. Whenever the distance is there, when the distance is given in kilometers, whenever the distance is measured in kilometers, then the time should be taken in hours. Time should be measured or taken in hours. So when you take the distance in kilometers, the time will be given in hours. So the speed will be calculated. The speed will be calculated as kilometers per hour, or we also denote it as kmph, which is again same, can be read as kilometers per hour, which is kmph. See, whenever the distance is in kilometers, when the question is given with the distance in kilometers, the time should be given in hours. If he gives the time in minutes or seconds, convert them into hours. The second thing, so how will we convert this time from minutes to hours? If he gives the time in minutes, how will you convert it? So for example, if he gives some time, for example 45 minutes he has given. He has given 45 minutes. How will we convert these 45 minutes into hours? So any minutes will be divided with 60 to get them into hours. So this is, try to cancel the things. 15 3s are 45, 15 4s are. So 45 minutes is nothing but 3 by 4 hours. So this is how we will convert the minutes into hours. The second thing, whenever the distance is, when the distance is measured, or when the distance is given in meters, when the distance is given in meters, then the time should be taken. The time should be taken in seconds. When the distance is given in meters, the time should be taken in seconds. Therefore, so the speed will be measured as meters per second, or we also write it as mps, which is also can be read as meters per second. So these are the first basic things we need to know before we solve the questions related to time and distance. See again, the distance is given in kilometers, then the time should be taken in hours. So the speed will be calculated in kilometers per hour. When the distance is given in meters, you need to take the time in seconds. So the speed will be calculated as meters per second. Now see, whenever we solve some questions, for example, let's see a person travelled a distance of 100 meters. A person travelled a distance of 100 meters. For example, 100 meters distance, for example, he travelled in 2 minutes if I say. So this is meters, this is minutes. As when you see this, there are meters and minutes, so you will convert it into seconds. For example, this minutes is converted into seconds by multiplying with 60. So now you will get the answer in meters per second. Now the answer will be meters per second. But if you have the options in kilometers per hour, if the options are there in kilometers per hour, how we are going to convert it? How we are going to convert it? Let's see that. Let's write a few conversions. I'll write here the conversions. So the conversions are very important. Let's see that. So the first conversion is how to convert the kilometers per hour to meters per second. How we are going to convert the speed from kilometers per hour to meters per second. How will we convert the speed from kilometers per hour to meters per second? Let's see. So I'll write here 1 kilometer per 1 hour. So this line is called R per, we have seen it in percentages. So 1 kilometer is nothing but 1000 meters, and 1 hour is 60 minutes, and each minute is 60 seconds. So 1 hour will be 3600 seconds. So 1 kilometer I have written it as 1000 meters, and 1 hour is 60 minutes, each minute is 60 seconds. So 1 hour is 3600 seconds. Now try to cancel these two zeros here. Now this is 2 5s are 2 3s are. Now what is left? 5 by 3 into 6 is 18 meters per second. Now what we understood from this, so whenever we need to convert the speed from kilometers per hour to meters per second, when the speed from kilometers per hour to be converted it into meters per second, multiply the given speed with 5 by 18. So multiply the given speed with 5 by 18. Let's write a small example how to change this. For example, when I calculated a question, assume I got an answer as, for example, some 24 kilometers per hour. This is the speed I got when I calculated some distance division with time. So this is the speed a person traveled to go to a certain distance. Now I want to convert this into meters per second. So what we need to do? So 24 is the kilometers per hour, multiply it with 5 by 18. So multiply the given speed in kilometers per hour with 5 by 18 to convert it into meters per second. Now this will be 6 3s are 18, 6 4s are 24. So this will be 4 5s are 20 by 3, which is 6.67 meters per second. So this is how we will convert. So if you want to convert the speed from kilometers per hour to meters per second, multiply the given speed with 5 by 18. Now let's see the second conversion. Let's see the second conversion. The conversion number 2, when we get the speed in kilometers per hour, to convert it into meters per second, we have seen it multiplying with 5 by 18. Now we have the speed in meters per second. We have the speed in meters per second. I want to convert it into kilometers per hour. So this meters per second speed has to be converted it into kilometers per hour. So how will we write it? Let's see, this is 1 meter per 1 second. So 1 meter per 1 second. So we need to know few things here. See here, for example, we just now written 1000 meters. 1000 meters is nothing but 1 kilometer. 1000 meters is 1 kilometer. Then 1 meter is 1 by 1000 kilometers. If 1000 meters is 1 kilometer, then 1 meter is 1 by 1000 kilometers. Similarly, 3600 seconds. 3600 seconds is 1 hour, then 1 second. Then 1 second is 1 by 3600 hours. So 1 meter is 1 by 1000 kilometers. Similarly, 1 second is 1 by 3600 hours. Now we'll write the same thing here. So 1 meter is 1 by 1000 kilometers. 1 meter is 1 by 1000 kilometers by 1 second is 1 by 3600 hours. Okay. So 1 meter is 1 by 1000 kilometers and 1 second is 1 by 3600 hours. Now what will happen? This is 1 by 1000 will remain same, and 1 by 3600 will become 3600 by 1. Cancel the 2 zeros here. This is 2 5s are 2 18s are. So which is 18 by 5 kilometers per hour. So 18 by 5 kilometers per hour. Now what we understood from this, to convert any speed from meters per second to kilometers per hour, to convert any speed from meters per second to kilometers per hour, multiply the given speed with 18 by 5, multiply the given speed with 18 by 5. Let's write an example. For example, so let's write a speed of 30 meters per second, a speed of 30 meters per second. Now this to be converted it into kilometers per hour. Now how will we convert it? So 30 into, to convert any speed from meters per second to kilometers per hour, multiply it with 18 by 5. To convert any speed from meters per second to kilometers per hour, multiply it with 18 by 5. This is 5 ones are 5 6 are 5 ones are 5 6 are 30, 18 6 are 108 kilometers per hour. 108 kilometers per hour. See, 6 8s are 48, 6 1s are 6 plus 4 10. So we'll see the previous case where to convert the speed from kilometers to meters per second, multiply the given speed with 5 by 18. Now in this case, to convert the speed from meters per seconds to kilometers per hour, multiply the given speed with 18 by 5. These conversions are important. We will use everywhere to solve to solve the questions by using the conversions. So remember this. Again, from kilometers per hours to meters per second, it is 5 by 18, and from meters per seconds to kilometers per hour, it is 18 by 5. Let's see one more concept here called average speed. So let's see the concept, name average speed. Average speed. So the average speed concept. In this, let's imagine a person traveled to a place with the speed some s, and he traveled another equal distance of speed with another equal distance with the speed some p or something. Then to travel this total distance, with what average speed he traveled, that is this concept. Let's see, a person traveled a total distance, for example A to B is, A and B are two places, A and B are two places. In this, so A and B are two places. In this, a person traveled first half of the distance. A person traveled first half of the distance. For example, think this is total distance is d, this is total distance is d kilometers, total distance is d kilometers, and a person traveled first half of the distance d by 2 with the speed s1, and next half of the distance d by 2 with the speed s2. So basically what we are saying, if a person travels half of the distance with the speed s1 and half of the distance with the speed s2, that means when the distances are equal, when the distances are equal, when the distances are equal but different speeds, when the distances are equal but different speeds, then average speed in this case, the average speed is written as 2 into s1 into s2 by s1 plus s2. See, this question may be asked as a bus travelled from Hyderabad to Vizag with the speed 60 kilometers. Again it travelled from Vizag to Hyderabad with the speed 70 kilometers. What is the average speed? See, Hyderabad to Vizag and Vizag to Hyderabad, the distance is same, only the speeds are changing. So the average speed is 2 into s1 s2 by s1 plus s2. This is the first case. When we have two equal distances, this is the case. But what will we do when a single distance d is made into different speeds? When a person travelled different speeds, for example, first a person travelled a distance of d1, next he travelled a distance of d2, next he travelled distance of d3, and so on. There are many other things. So first distance he travelled with the speed s1, or let's take it as with the speed s1, let's this take it as speed s2, let's this take it as speed s3, and speed s1 and time t1, let's take this speed s2 and time t2, speed s3 and time t3, like that. Now see, in the previous case there were two equal distances, but here these distances are not equal and the total distance is made into separate groups, separate parts. So how will we find the average speed in this case? So the average speed in this case, the average speed in this case is given as the total distance travelled, the total distance travelled by the total time taken, the total distance travelled by the total time taken. This is how we will calculate the average speed. See, in the first case the distances are equal but only the speeds are different. Distances are equal and speeds are different, so the average speed is 2 into s1 s2 by s1 plus s2. But when you come to the second case, the distances are not equal and the speeds are not equal, times are not equal. So in this case we will use what is the total distance he travelled by what is the total time taken to travel these different parts of the distances. So this is how we will calculate the average speed. Okay, let's see one more concept before going to the questions. The concept name is relative speed. Relative speed. So relative speed speak about the difference of the speeds between two vehicles or the two persons, but in this case the vehicles or the people may be, travelling in the same direction sometimes, or they may be travelling in the opposite direction. Let's see, first one I'll write, when two vehicles or two people are travelling in the same direction, So when they are moving in the same direction, let's see what is the same direction means. Let's see that. So imagine we have two cars. This is a car travelling with the speed s1 in this direction. Imagine the car is travelling with the speed s1 in that direction, and you have another car which is travelling with the speed s2 in the same direction. This is the same direction. When both the vehicles are moving in the same direction, when these two are moving in the same direction, then the relative speed will become, s1 minus s2, provided s1 should be greater than s2, or you can also write it as s2 minus s1 provided s2 is greater than s1. That means whatever the highest value, you subtract the lowest value from it. That will be the relative speed in this case. So the speed will be written, speed s is equals to distance by time, but in this case the relative speed is, for example, I will take s1 minus s2, so it will become s1 minus s2 is equals to d by t. S1 minus S2 is equals to d by t. This is when two vehicles are moving in the same direction. So when two vehicles are moving in the same direction, the relative speed will become the subtraction of both the vehicles. That means we will take the subtraction, the difference of the speeds of those two vehicles, to calculate the relative speed. So in this case, the original speed formula S is equals to d by t will be written as S1 minus S2 is equals to d by t. Now the second part of the relative speed, the second case is when they are travelling in the opposite direction, when they are travelling in the opposite direction. So travelling in the opposite direction, we will write, let's see how they move. So let's take a vehicle. Imagine this is a vehicle, and we have one more vehicle. Assume the first vehicle is moving like this with the speed S1, and if the second vehicle is moving like this with the speed S2. If the first vehicle moves like this way with the speed s1 and the second vehicle moves in opposite to it with the speed s2, then this is called as the opposite direction. Then in this case the relative speed will become, in this case the relative speed will become s1 plus s2. The relative speed will become s1 plus s2. See, in the case when both the vehicles are moving in the same direction, the speeds were subtracted. That means we took the difference of the speeds as relative speed. But when both the vehicles are moving in the opposite direction, the relative speed will be the sum of their speeds. So it will become s1 plus s2. So in this case s is equals to d by t will become, s is nothing but s1 plus s2. S is nothing but s1 plus s2, which is equals to d by t. That means whenever we solve a question about relative speed, the original speed will become, in the same direction the original speed will become s1 minus s2, and in the opposite direction the speed will become s1 plus s2. So these are the concepts. Remember, when we see the third case in this, actually this third case is not necessary, but if you see different directions, if I write different directions, when we see the different directions of two vehicles, for example, if this vehicle is moving like this with the speed s1 and this vehicle is moving like this with the speed s2. So both are moving in the different directions. So in this case the relative speed will become 0. You cannot find out the answer because it will be 0, because they are not at all going to be contact with each other. They are not at all going to be cross each other. So one is moving this direction, another is moving that direction. So the relative speed will become 0. So remember these concepts, the basic concepts, how we have converted the speeds from kilometers per hour to meters per second, and how we converted the speed from meters per second to kilometers per hour. Then remember the concepts of relative speed and average speed. Then we will solve some questions about this. We will start with the basic question. Let us see the question 1. A boy goes to a place at a distance of 900 meters in 6 minutes. Find his speed in kilometers per hour. A boy goes to a place at a distance of 900 meters in 6 minutes. So the distance he has given and time he has given, and he is asking us to find the speed in kilometers per hour. See what it is, s is equals to d by t. So it is so distance is 900 meters by time he has given 6 minutes. See, when we are writing the basic notes of time and distance, we have written it. When the distance is in meters, the time should be taken in seconds. When the distance is in meters, the time should be taken in seconds. So the distance is in meters, 900 meters by time is 6 minutes. So 6 minutes, that means each minute. So each minute is 60 seconds. So it is m by s. So 900 meters by 6 minutes, each minute is 60 seconds. So 6 minutes will be 6 into 60 seconds. Now try to cancel the things. So zeros will cancel. So 90 by 6, 6 ones are 6 15s are 90. Now what we left with, this is 3 2s are 3 5s are 3 2s are 3 5s are 15, which is 5 by 2 meters per second. So the distance 900 meters will be travelled in 6 minutes with the speed 5 by 2 meters per second. But what we required the speed in kilometers per hour. So to convert any speed from meters per second to kilometers per hour, multiply it with 18 by 5. To convert the speed from meters per seconds to kilometers per hour. This is the note we have already seen. So this is 2 ones are 2 9s are 5 ones are 5 ones are. So which is 9 kilometers per hour. So it will be 9 kilometers per hour. So what we have done, he has given 900 meters as the distance, the time is 6 minutes. So whenever the distance is there in meters, the time should be taken in seconds. So 900 meters by 6 minutes is 6 into 60 seconds. So 0 will cancel, 6 1s are 6 15s are, or 15 6s are 90, and this is 3 2s are 3 5s are. So 5 by 2 meters per second is the speed, but he asked the speed to calculate in kilometers per hour. So 5 by 2 into, to convert the speed from meters per second to kilometers per hour, multiply it with 18 by 5. So 5 by 2 into 18 by 5, 5 will cancel, 2 1s are 2 9s are, so which is 9 kilometers per hour. So this is how we will convert the speed from meters per second to kilometers per hour. Let us see the question. Anirudh, walking at 4 by 5 of his usual speed, misses the train by 15 minutes. Anirudh, walking at 4 by 5 of his usual speed, misses the train by 15 minutes. What is the actual time required to reach the station? See, basically Anirudh will travel with a certain distance to reach to the station, but he travelled with the 4 by 5th of his original speed. That means he reduced his speed was decreased. Because of this, he misses the train by 15 minutes. That means he reached the station 15 minutes late. He reached the station 15 minutes late. Now what he is asking, what is the actual time required to reach the station? What is the actual time required to reach the station? So let us see that. There are so many methods to solve this question. So we will see a shortcut method first, otherwise we will see a traditional method first. Let us see, we will have a different cases here. S is equals to d by t, this is what we will use. We will see the traditional method first. So S is equals to d by t. The first case is, see, first case I will write the case 1. Let us take his original speed is S, the distance travelled is d, by time is t. Let us take it as, so original speed is S, original distance travelled is d, and time is t. Now let us see the case 2. What we can write in case 2? Now what happened in case 2? He travelled with 4 by 5th of the original speed. He travelled with 4 by 5th of the original speed, but distance is not going to be changed. Distance is going to be same, but this time he misses the train by 15 minutes. That means he reached the station 15 minutes late. He reached the station 15 minutes late. Original time is t minutes only, but he missed the train by 15 minutes, means he reached the station 15 minutes late. So first case is S is equals to d by t, and second case is 4 by 5 of speed is equals to distance by t plus 15. Why we have written plus 15? Because he reached the station 15 minutes late. That means he took 15 minutes more time to reach the station. Now check this, I will substitute this S is equals to d by t here. S is equals to d by t, I will substitute there, which is 4 by 5 into d by t is equals to d by t plus 15, d by t plus 15. So here d and d will cancel. Now go for cross multiplication. This is 4t plus 15 4s, 4t plus 15 4s, 4t plus 15 4s 60 is equals to 5t. 4t plus 15t is a 4t plus 15 4s are 60, 5 into t is 5t. So this is 5t minus 4t, t is equals to 60 minutes, because we are calculating the time in minutes, so it is 60 minutes. Now what is the question? What is the actual time required to reach the station? So t is equals to 60 minutes. Therefore the actual time required, we will write it here. So actual time required, so actual time t is equals to 60 minutes, means he requires actually 1 hour to reach the station. So he requires 1 hour time to reach the station. This is one method. What is the traditional method? So we have taken S is equals to d by t. In the case 1, I have taken his speed as S, distance as d, time required is t. Now second case, he has travelled with 4 by 5 of the usual speed. So 4 by 5 of S is equals to d by t plus 15. Why we have taken this 15? He has taken 15 minutes more. So add it to the original time. Now substitute this s value in 4 by 5 of s, which is 4 by 5 into d by t is equals to d by t plus 15. D will cancel. This is 4 into t, 4t plus 15, 4s are 60. This is 5 into t, 5t, t is equals to 16 minutes. This is a method to solve this question. Otherwise, let's see. Let's take the original speed, I'll take it as actual speed. Actual speed, let's take it as s. The actual speed is s. Then the changed speed I'll write here. Changed speed, the speed which he is changed to, which will become 4 by 5 of s. So the speed changed is 4 by 5 of s. Now let's see what we can write here. So we can write here the ratio of the speeds, ratio of the speeds. So speeds ratio I'll write, speeds ratio. So the speeds ratio is s is to 4 by 5 of s. So the speeds ratio is s is to 4 by 5 of s. So s will cancel, it will become 5 is to 4. It will become 5 is to 4. So the speeds ratio will become 5 is to 4. Remember, we have written the speed is inversely proportional to the time taken. The speed is inversely proportional to the time taken, because speed is equals to distance by time. Now speeds ratio is 5 is to 4, then time ratio, the time ratio will become times, I'll write. So times ratio will become 4 is to 5. So times ratio will become 4 is to 5, because this is inversely proportional. So speed will become 5 is to 4 and times will become 4 is to 5. Now take any one thing, for example, I'll take these two things. Okay, I'll take these two things, but before that check the difference between the times. So this is 4 ratios, this is 5 ratios. So difference of times is 5 minus 4, which is 1 part. In ratios we will count them as parts. So it is 4 parts is to 5 parts, so difference is 1 part. Now see, this 1 part difference is calculated how much? 15 minutes. This is the difference. So 1 part difference. So 1 part difference is nothing but 15 minutes. 1 part difference is 15 minutes will take. So actual time required, see this is, see it is a changed speed. So actual time required is 4 parts here. So actual time required is 4 parts. So actual time required. So actual time required is 4 parts. That means 1 part is 15 minutes. So 4 parts is 4 into 15, that is 60 minutes. So 1 part is 15 minutes is the difference. So 4 parts is 4 into 15, that is 60 minutes, which is equals to 1 hour. So we can solve anyway. The first method is traditional and second method. See what we have done in second method. We have taken the actual speed as s and the changed speed is 4 by 5 of s. So speeds ratio s is to 4 by 5 of s, which is 5 is to 4. As we know, this speed is inversely proportional to the time. So 5 is to 4 of their speeds will become 4 is to 5 of the time periods. Now difference between the time periods is given as 15 minutes in the question, but here it's 4 parts and 5 parts, which is 5 minus 4, that is 1 part. So it is 5 minus 4, 1 part. So 1 part is 15 minutes, that's what he mentioned in the question. So 1 part is 15 minutes, so 4 parts of the time. So 4 into 15, that is 60 minutes. So 60 minutes is the time taken, actual time required. So 60 minutes is the actual time required by the person to reach to the station. So this is how we can calculate. In both cases we will get the same answer. Let's see the next question. In a bike race between two people, they traveled with the speeds of 60 kilometers and 64 kilometers per hour respectively. That means at 60 kilometers per hour and 64 kilometers per hour. Here it is 60 kilometers per hour, like this. So in a bike race between two people, they traveled with the speeds 60 kilometers per hour and 64 kilometers per hour respectively. Find the distance traveled by them if the slower one takes 1 hour more than the other. If the slower one takes 1 hour more than the other. That means if they started their bike race from a place to another place, so what is this distance traveled? What is this distance traveled? That's it. We need to find this distance. Now see, let's see the answer. So how will we solve this? Let's see, first we will take the speeds ratio, I will write, we'll use the trick first. So the speeds ratio I will write 60 is to 64. So the speeds ratio is 60 is to 64, which is 4 table will use 4 15s are 60, 4 16s are 64, 4 15s are 60, 4 16s are, which is 15 is to 16. So the ratio of the speeds is 15 is to 16, and the times ratio. So the ratio will be taken. Just now we have seen it. The speed is inversely proportional to the time. Speed is inversely proportional to the time. So the speed is inversely proportional to the time. So it is 1 by 15 is to 1 by 16. So it is 1 by 15 is to 1 by 16. That is 16 is to 15. So the time will be 16 is to 15. Now you see, if you see the time difference, 16 parts minus 15 parts, which is 1. 1 part is the difference. 1 part is the difference, which is equals to 1 hour. 1 part is equals to 1 hour. So there is nothing. So 1 part is equals to 1 hour will take. Now see, if you want, you can take the first person, or you can take the second person. See, the speed of the first person is 60 kilometers per hour. Now how much time he traveled? 16 hours. So the distance traveled is, distance is nothing but speed into time. So speed is 60 kilometers per hour into time he traveled is 16 parts. Time traveled is 16 parts. So 60 into 16 is 960 kilometers. So I found the distance by using the first person's values, or we can calculate the distance, same value, by using the other person. So we will calculate the same distance. We will calculate the same distance by using the values of the other person. So let's see whether we will get the same answer or not. So distance in this case is, see, the second person traveled with a speed of 64 kilometers per hour, and he traveled for 15 hours. So it is 15 4s are 60, 15 6s are 90 plus 6, 96. So in any case you will get the same answer, which is 960 kilometers. This is how we will take the ratio of the speeds. From that we will take the ratio of the times. That means the time is inversely proportional to the speeds. So this is one method. Or how can you solve this question by using the traditional method? How can we solve this? Let the speed is s is equals to d by t. Let's write it directly. So first case, see, he traveled, one person, the first person traveled with the speed 60 kilometers per hour. Distance is d, but time, let's take it as t plus 1. Distance is d, time is t plus 1. Why we have written 1? Because he said the slower one takes 1 hour more than the other. The slower one takes 1 hour more than the other. You can write case 1 or first person, anything is okay. So this is first person. Now this you can write it as d is equals to 60 into t plus 1. D is equals to 60 into t plus 1. This is for first person. Now let's write it for the second person. So first person takes 1 hour more, that means t plus 1 we have written. Second person speed is 64, distance is d, time is t hours. So this distance will be d is equals to 64 into t. Distance d is 64 into t. So for first person, let's take equation 1 and this equation 2. Both are denoting the distance only. Equation 1 and equation 2 both are denoting the same distance. So from two equations we can write as 64t is equals to 60t plus 60. 64t is equals to 60t plus 60, which is 4t is equals to, so 64t minus 60t is 4t is equals to 60. So this is t is equals to, this is 4 1s are 4 15s are. So t is equals to 15 hours. So the original time required to complete the race is 15 hours. So in this 15 hours, what is the distance that is travelled? So you can take any equation. Let me take the first equation 1 to find out the distance. So equation 1, distance d is equals to 60 into t value is 15 plus 1. So 60 into 16, which is equals to 960 kilometers. So this is the distance. So first case we solved the question by using the ratios, and second case we solved the question by using the traditional method, that means by using the formulas. So in both the cases of the second way, both the cases are denoting the distance d, so we equalized the distances to get the answer. So this is how we will calculate this type of questions. Let's see one more question. From his house, walking with a speed of 3 kilometers per hour, Sunil reaches his office 10 minutes late. If he walks with a speed of 5 kilometers per hour, he will reach 10 minutes early. Find the distance between his house and office. Interesting question and important question. Let's see. If a person goes with a speed of 3 kilometers per hour, he will reach office 10 minutes late. If a person goes with a speed of 5 kilometers per hour, he will reach the office 10 minutes early. See, let's take a small thing here. If the office timing is at 9 a.m., office timing is at 9 a.m. For example, if I say, so I reached the office 10 minutes late. 10 minutes late means at what time I reach? 9 plus 10 minutes, that means I reached 9:10. Okay. If I reach the office 10 minutes early, I reached the office 10 minutes early means 9 minus 10, that means 8:50 a.m. is the time I reached the office. So 10 minutes late means add the time to the original time. 10 minutes early means subtract the time from the original time. So we will use this to solve the question. Let's see. So S is equals to d by t. Let's see. In the first instance, he traveled with a speed of 3 kilometers per hour. We don't know the distance d. Let's take the time required is t minutes. Let's take the time required is t minutes. So distance and original time is t minutes, and because of 3 kilometers per hour speed, he reached the office 10 minutes late. 10 minutes late. So because of he traveled with the speed 3 kilometers per hour, he reached the office 10 minutes late. So distance d is equals to 3 into t plus 10. Now in the case 2, he has traveled with a speed of 5 kilometers per hour. Distance will remain same from home to office or office to home. This time he reached the office 10 minutes early. So early means subtract it. Now here the distance d will be written as 5 into t minus 10. Distance d is 5 into t minus 10. Now see, both will denote the same thing. So I can write here as 5t minus 50 is equals to 5t minus 50 is equals to 3t plus 30. So this is 5t minus 3t is 2t. This is 50 plus 30 is 80. So 2 ones are 2 40s are. So the actual time required to reach the office is 40 minutes. The actual time required to reach the office is 40 minutes. Now take any one thing. I'll take this equation to find the distance. Let's write d is equals to 5 into t is 40 minutes minus 10. This completely is in minutes. This is in minutes, but this 5 is in kilometers per hour. Now see how will we write? This is 5 into, this is 30 minutes by 60, that means hours. So that 30 minutes is being converted into hours by dividing with the 60. So 30 ones are 32s are. So 2 ones are 2, 2.5s are. So the distance between house and office is 2.5 kilometers per hour. So the distance between house and office is 2.5 kilometers per hour. See what we have done. So in the first case, when he traveled with a speed of 3 kilometers per hour, he reached the office 10 minutes late. So we added the 10 minutes to the original time t. In the second case, he traveled with a speed of 5 kilometers per hour. So he reached the office 10 minutes early. So we subtracted 10 minutes from the original time t. Now both the cases are denoting distance d. So equalize them. 5t minus 50 is equals to 3t plus 30. So which is 5t minus 3t is 2t is equals to 50 plus 30 is 80, that is t is equals to 40 minutes. So, this 40 minutes is nothing but the actual time required to reach office from home. Now, take any equation. So, I took the second equation, distance d is equals to, this is 40 minutes minus 10 minutes is 30 minutes, that is half an hour it is. So, 30 by 60 hours, which is half an hour. So, 2 ones are 2 5s are, which is 2.5 kilometers is the distance between house and office.